Alrighty, hi everyone. I'm Allison, if you forgot my name in the last couple days. But thanks for coming tonight. Figured I would have this just to get started. I know we don't have a lot of class already. But just a little bit about how I do office hours and stuff. I tend to hold these like a review session, so you can come and ask me any questions from class that you want. It can be class, it can be iClicker, it can be your homework, it can be life. I don't really care. But we'll go over that, answer your questions, hopefully do a couple practice problems along the way to kind of help you with that, just so you see another version of that. I was a tutor all throughout undergrad, so I always thought the best way to learn chemistry was to practice it. So I just tend to try and give you as many practice problems as possible along the way. I'm the IA for Chem 120 as well, so that's just what's in here beforehand. Feel free to come in whenever. I don't mind. We'll have a transition period so that, right, you can come and ask me questions beforehand or after, so no problem there. Usually I do this on my iPad and it'll be projected up here for you to see. I just forgot my Apple Pencil in my other bag, so we'll do it by the chalkboard today, and then next week I promise I'll be more prepared. And then you might have heard that on the way in, but I will do this every week. I'll make an announcement every week as well, but they will all be Zoom recorded and then posted on Canvas. They get posted to YouTube as well. So I've been doing this for 4 years. So I have videos from Chem 107 from last year when I taught with Dr. Bengali, Chem 107 from when I talked with Dr. Altimos, and then like 119, 120 videos. So you can feel free to peruse my YouTube as much as possible. There's additional practice problems in there as well. And then everything that's on Canvas is all linked here. You'll have all the videos from last year that you can see underneath as well. So there's practice problems there and all that stuff that you might need. I'm here to help you. So if there's anything more I can do for you, please just let me know. I'd be happy to do that. And then while you're here, feel free to just ask me any questions. I don't really have like a set schedule or set plan. I just want to tailor it towards you and then get your questions answered. So that's my plan for these. Any questions for me? Yeah. It's just Allison_Getz, I think. Let me look. It's associated with my TAMU account. So sorry, I lied. It's AllisonGetz214. Feel free to like, subscribe, and follow. Couple of times I get a thumbs down video and that makes me sad. Most of the time they give me a thumbs up. All right, anything else? Okay, what would you like to see today? I know we haven't had a lot of class. Yeah.
No, the next thing, I think, we left off on how to calculate percent buttons.
Mhm. Yeah, absolutely. So can you tell me what percent abundance is? What does that mean? So if we look at percent abundance, we're looking at the amount of isotope in, we'll call it the atom. Okay. So does anyone know of an element that has an isotope?
We looked at uranium.
Uranium is one of them. Right, uranium-235, I believe, is the radioactive one. But uranium is definitely a isotope atom. Anything else? It's kind of a trick question. I think they all have isotopes of some sort. Right, so we can have like carbon-13 is one of them. Right, usually we have carbon-12. Oops. Right, carbon-12. Right, carbon-14 dating. Right, that's another isotope. So carbon has a couple of them. Phosphorus, P32, is another isotope. That's a radioactive one. Oxygen has oxygen 18. So, right, pretty much all of them have a isotope, whether it be a very small quantity or a large quantity. Everything pretty much has an isotope. Some of them radioactive, some of them not. 4% abundance, what you're looking at is that the amount of that isotope contributes to the mass of that isotope. So on the periodic table, when you have carbon 12.01, this mass here comes from the weighted average of the isotopes. Right? That's what you're finding for when you're looking for percent abundance or average atomic mass. Right, so percent abundance, average atomic mass, all kind of working together. So if we were to look at right, you have a question in your slides that says you have boron 10. And you have boron 11. Right, and we want to know, it asks for the percent abundance of 11, but I want to know the percent abundance of B10. Okay. How do we solve for the percent abundance? Do we have a formula for that?
Add them and then multiply them and then add each isotope.
Yep, so your average atomic mass is right, the mass of isotope 1 times percent abundance of 1 plus the mass of isotope 2 times the percent abundance of 2. Right, it's a weighted average for the isotopes in your compound or in your atom. For boron, we know that there's only these two atoms or these two isotopes for boron. Okay, so do we know how much either one of them makes up? We don't, right? We don't know how much of 10 there is. We don't know how much of 11 there is. But what do we know that they have to add up to if they're percent abundances? They have to add up to 100%. So that can either be 100% or 1. So in this case, if we're going to say, right, we're going to make a chart, this is percent abundance. If the percent abundance of B is X, what does that mean that the percent abundance of B11 is? (100 minus X, right? It's 100% minus X. So if we're going to transfer that out of 100%, it would be 1 minus X. That's what we're going to use, right? whatever 10 makes up, 11 is gonna make up the rest. Where do we get our average atomic mass from?
Multiply the percent abundance by the weight of both of them united together.
Yep, and that would be if we knew the percent abundances. We don't in this case. So where can we find this? We don't know. The periodic table, yep. So, right, this is the weighted average of our isotopes. And that means that the true value, or whatever this atomic mass is gonna be on our periodic table. So if you don't know what those percent abundances are, then you can look at the periodic table. If you're given the percent abundances, then you do what you originally said, right? And you can just multiply them together. This case is like a little harder than in that because you have X's involved. And your X is not the average atomic mass. So if we look at the periodic table, boron is 10.81. Is that what I read? Yeah, 10.81 for its atomic mass. So before we even do our question, is 10.81 closer to 10 or closer to 11? It's closer to 11. So do we think that it's going to be more, is there going to be more B11 or more B10 for our isotopes? More of the 11, right? This is closer to 11, which means that there's more of the 11 to pull that average closer to 11, right? If it was 10.5, then it would be 50-50, right? Because it's right smack dab in the middle. But this one's a little bit closer to 11, so we should expect a higher percent abundance for 11 than for 10. Okay, so now we can set this up. We said that our mass of B10 is 10.0129. And what do we say its percent abundance was? X. We're gonna add that to the B11, which is 11.009. And what did we say that percent abundance was? 1 minus X. Perfect. How do we solve for X now? Distribute, right? Now we can just solve like usual PEMDAS. So we have 10.81. So I combined X, saw this was negative, so I added it to both sides. That's why that's there. And then I subtracted 10 from there. So that's why that's there. Okay, then we can divide. And I got X equal to 0.1999997, which is essentially 0.2. So is that our percent abundance for 10?
Yeah. You can put it in the, for the, lab induction.
So our question here is just for B10. So we can find for both and that would be fine. But yes, right, if you were solving for B11, you would have to plug it in and solve for B11. What do we need to do? Can we leave it as 0.2? Yep, we multiply it by 100 and then get the percentage. So this would be 20% B10, I guess. Okay, so what would our percentage of B11 be? It would be 80%. Right, because we just did 1 minus 0.2. That makes sense how we solved it with the x's. Okay. Right, a good thing to note here is that our question asked for the percent abundance of 10. We made x 10 already. So that meant that when we solved for x, we got our answer directly. If it asked for B11, you could have said that your x was 11 here, right? This was x, this was 1 minus x. That way, again, when you solve for x, you directly get to 80%. Okay, so that's just like planning ahead. But you just want to make sure you understand which one's x and which one's 1 minus x in this case. And if you can set yourself up to get x directly, then that's always a positive. Hi. To help a little bit with percent abundance there. You could do it also a little easier. Right, and you could just say we could also do this one here. So we have an atom has 3 isotopes. Isotope 1 is 15.775 with 14.33%. Isotope 2 is 17.210 with 63.45%. And then isotope 3 is 18.147. And I want to know what the average atomic mass of that atom is. How would we solve this one?
Subtract the two percentages, add it together from 100%.
Right, so the first thing we need to do is we need to figure out what this percent abundance is. We could take 100, subtract that from the addition of 14.33 plus 63.45. This. So that's telling us that our isotope 3 is 22.22%. Here, this is when I look and I say, okay, am I expecting this to kind of fall? Where do we think we should expect our average atomic mass to be? Yeah, right, probably somewhere in the isotope 2 range. Right, if this is our halfway point, because it's 63, right? Isotope 3 has a little bit more pull than isotope 1, and these are both heavier than isotope 1. So, right, we should be somewhere in that 17 range. Okay, now what can we do now that we have our percent abundance for everything? Yep, we're going to convert all these to decimals, right? So this just turns into that there. And then what do we do from there? Then you just plug and chug. Yep. So we have average atomic mass. We have 15.75. Right, you can just use this here. We've got 17.213. You can check.
So on this question, it says the atomic weight of bromine is 79.9 AMU. And, that is like one of the isotopes, and it says it has a specific AMU, and then a second isotope for bromine that's a different AMU.
Mhm.
What are the percent isotope abundances? How would we find that with that information?
Yep, so that's very similar to this one here, right? So before I do that, let me just wrap up this question. Right, so just looking back at our average atomic mass, we expected it to be close to isotope 2, and it's essentially isotope 2. So that's good there. Any questions on plugging and chugging it that way? Right, so you have bromine is, what's its average atomic mass?
79.9.
And then you have bromine,
79.
and that, is that just 79 AMU?
It's 78.918338.
And then you have bromine, what else?
81.
Mhm.
80.916291.
Okay, awesome. So, right, we have bromine is 79.9. We have 2 bromine isotopes. We have 78.918, and we have 80.916. Just looking at this, what's in the middle of these 2 isotopes? Right, this is, right, what would we round this to? We round this to 80. What are we gonna round this to? 79. What are we gonna round this to? 81. What do we notice about our isotopes and our average atomic mass? It's right in between, right? So these should be about 50-50, right? So you might get lucky and plug in 50-50 and get the correct answer without doing any math. But in order to do math, right, this is gonna be very similar to our first boron example. So we have 79.9 AMU. We have our first isotope. What's its average atomic mass of isotope 79? We don't know, right? That's what we're solving for. So that's gonna be X. And then we have our other isotope, 80.91629. What's that average, or what's that percent abundance? 1 minus X, yep. Okay, so let's solve this. Let's see what our X is, and then what our 1 minus X is. Should be like 49.9 and 51, or 50. So I got X is 50.9% and 1 minus X is 49.1%. Because X comes out to 50.86, so I rounded that last one. 3 sig figs. So which one is the 50.9? Boron 79, right? Or bromine 79, right? This is bromine 79, and this one is 81. It's pretty close to 50-50. Hey, does that make sense how you would solve that question? Does that help with percent abundance there? They're pretty cut and paste. You could do one of 3 and you don't know 2 of them, right? So if you don't know 2 of them, right, if we were given 0.222, then you would subtract that from 100, and then you would have X and 1 minus, or, and then 0.78 minus X, this one. Yep,
This question, it wouldn't be like exactly this. It would be like, close to, because I know for the first one that we did, we got 20%, but on multiple choice, the only closest was 19.9.
yeah, so, and then the first one was like, it just depends how many sig figs you keep in your calculator along the way too, right? If you rounded early, then it might have given you that 19.9. But it'll be pretty, like, pick your closest one. 19.9 is close enough to 20, that would be your correct answer. And then for multiple choice questions, right, you can always plug that answer into your formula. So you can always check it that way too. That's nice. Mhm.
Question is, breakdown about, 4 sets of isotopes.
Mhm.
There is a table that provides the identity of, two pairs with the atomic weight. In each case, the 2 isotopes differ in mass number by 2. Is asking which element has the mass of the spectrum that I see in the graph.
My fault. that right in terms of the lines where it's crossing? Does it go above this one? A little bit above? Like that? Okay, cool. So, right, we have two peaks of your atom, right? So this is showing that your isotope has two isotopes in it, right? You're given 4 questions or 4 options for what the isotope might be. So what you want to look at is you want to look at the relative abundance of these 2 isotopes. Your masses come out, small mass over here, and then larger mass over here. So in this case, which one is more abundant, the smaller mass or the larger mass? The smaller mass is more abundant, which means that we need more of that lower isotope to pull down that average atomic weight. What is our ratio-ish of our 2 isotopes? Right, if it was 50-50, what would it look like? Right, if it was 50-50, it would look like that, right? But it's not like that. We have a little bit above and then a little bit below. So what do we think that probably is gonna be?
70%.
Right, I would say that. Maybe this is, yeah, so this one probably, right, like that much. So I would say, from my first glance, right, it's not 50-50, you have a little bit above, a little bit below. This is gonna be 67%, and this is gonna be 33%. Right, we have a 2-to-1 ratio, or, right, 2/3 to 1/3. That would be my guess. Okay, so that's relative percent abundance is 67 and 33. So now you need to pick the options in your question for which one has a small mass that's about 67% abundant and the large mass that's about 33% abundant. Are you given the average atomic mass for all of them?
Yes.
Yeah, so then you can kind of look at your isotopes, right, and you can say, and then you can kind of plug in the formula for all of them and see which one comes out that your smaller mass is about 67% and your larger mass is about 33%. So can you give me an example of like what the first,
The first answer would be 1.1 SB.
SB, yep,
and 1.3.
okay, so,
Average 1.1.
right, that's your average atomic mass. Okay, so we can plug this in, right, and we can say 121.8 is equal to 121 times x plus 123 times 1 minus x. Right, if we just do that quickly. So this is 0.6, so this is about 60%. Right, that's pretty close to 67. That might be our answer, right? I would go through and just check to see if any of the other ones are closer to 67. But this looks promising just from the first initial look at it. Mhm. Does that make sense why it's like 67 and 33%? Yeah. Anything else? Do you feel more comfortable with percent abundance? Anything else we want to see today? So far?
Yeah, structure.
Yep, so mostly structure, there's, we talked a bit about, like, oh no, I forgot. The nuclide, right, showing it that it's. Right, you have like your X, what it is, A and Z. Right, that kind of notation, and then this is where your charges. Your atom, if you have one, we talked about that a bit. So your atomic symbols, we talked about ions, right, you can fill in the chart for protons, neutrons, and electrons of an atom. What else did we do? Right, we did all of your percent abundance stuff. The ions, yep.
Whenever you are increasing or increasing an electron, they have like a name, right?
Yes, yep, so. And if we have, let's call it N, right? If we're going to give this an electron, then it becomes N minus. This is now an anion. And then if we minus one electron, this becomes N plus. Then we have a cation.
And that is, anion.
And yep, and these are both an ion. Yep. Cation is always going to be a positive and anion is always going to be a negative. And I remember cation because it has the T in it, like a positive sign. People think, or I know people say cats have paws, like POS. I don't know. But, right. Cats have paws. This is like paws, a tit, can't read, right? But positive is what they're saying. I don't know. I just think the T is a positive sign, so. Anything else so far? Do we like chemistry? Are we chemists, right? Are we all chemists? No? Is this a class that we all have to be in just because? Little bit, that's okay. I promise chemistry can be fun. You have to get through the kind of boring part in the beginning, but you talk about some cool stuff as the semester goes on.
Do you have the slides from class?
I haven't pulled up yet.
on-
Mhm.
Did you do the dimensional analysis that we did with the hair?
Yeah.
and the atom? We did it in class and
Yes.
we had technology problems, so. we got a little-
He can get a little flustered sometimes, but he's so sweet. I worked with him last semester. He was so sweet. Okay. Okay, so we have, I'm just gonna summarize, right? Human hair is 7 times 10 to the -5 meters diameter. And then we're saying carbon atom is 1.4 times 10 to the -10 meters in diameter. So we want to know how many carbon atoms across a Right, this is the one you're talking about?
Yes.
Okay, perfect. Okay, so what do we think we have to do here? So, right, we're looking at, right, the picture is you have a human hair. And then this is the diameter, so then you have all of your carbon atoms across the diameter of your human hair. Okay, so we want to know how many of these guys fit in this guy, right? So is that going to be a lot or a little? That's going to be a lot, right? So in order to, in order to put carbon atoms next to each other, they only have a times 10 to the negative 10 meter diameter of your human hair. So what you're going to start off with saying is that, right, you have one human hair, right? And that's going to equal 7 times 10 to the negative 5 meters. We were looking for the number of carbon atoms. So if your meters are on top here, we're saying that one carbon atom has this many meters of diameter. Right, because we're looking for the number of carbon atoms. So one human hair has this many meters of diameter. One carbon atom has this many meters of diameter. So one human hair is this many meters. So if we have this many meters, in order to convert meters to carbon atoms, we have to divide by that carbon atom diameter. Right, just math in general, if you have a negative exponent in your denominator, that's going to make a really big number. So we expected this to be big, so that's good that that's in the bottom. So then we have this. So this is $500,000 carbon atoms, which was choice D for that question. Does that make sense how that is set up? Yes. Dimensional analysis can get a little tricky. I always try to show my dimensional analysis throughout the semester as brackets. And I will string them together as much as possible if I can. If you need me to break them up along the way, please let me know. But I like to show that all of the units cancel out. So if it ever gets confusing, just let me know. Anything else from class or homework or anything? Have we looked at the homework yet? Thanks. I will say that there is a lot of homework in this class, so just make sure you're keeping up on that. I do think it's very beneficial homework. I think it gives you a lot of practice and it kind of helps you out along the way. But sometimes it can be tedious with the amount of tasks it might look like.
Do you have any recommendations for studying?
Always. So I think it usually gives you like the week 1 notes at the beginning of the week. Take a quick preview at what that looks like. I personally think the best way to take notes in class is to have his notes either printed out or on some sort of tablet, and then you write directly on the slide. So that way you don't need to write down any of that information that's already on the slide. It's right there. You can circle things, you can highlight things, you can make notes in the margin. I always printed it out because I was like right before the tablet got big. Well, I was right before COVID when I was in college, so everything was paper then, but I would print it out in 4 different slides. And then you would just write on the slide directly. But if you can just make it a slideshow, then you can just follow along with the slideshow and make slides that way. I studied by doing that in class and then writing my notes again in a notebook, just so I had practice of writing everything down. And then I think the best way to learn chemistry is to do as many practice problems as possible. The more you practice, the more you look at questions, the more of the jargon and the phrasing of questions that you get. And if you can understand that type of question, then when you see something that you're like, I'm not really sure what that's asking for, you might be able to pick up keywords or say, oh, I've kind of seen that before, and have a way to solve it that way. So the more you familiarize yourself with questions, the easier it'll be when something that you haven't seen before pops up. I love CHEM10725. I wonder if I can find in this real quick. So ChemTeam.info I used in undergrad when I was a tutor, and then I've used it since I've been here too. But this is a site that has a whole bunch of practice problems. And it also has really good explanations. So if you go to this website, it's very cryptic. It like just has a weird hyperlink. You can trust it, you can click it. And then it brings you to a table of all the different topics. So you have like kinetics, equilibrium, stuff like that towards the end of the chapter. There's a whole topic that just says the mole, that you'll talk about the mole in that sense and using Avogadro's number. So this is a really helpful resource that doesn't belong to a university or anything, so it's very universal. And then it gives you practice problems for different topics, and then it'll like give you the problem and then give you the solution and walk you through the solution. So if there's a topic that you're not having or that you're having some trouble with, I just type like percent abundance questions chem team. That's usually the first link that pops up. And then it will walk you through those questions that way. So it's my system.
I have a question.
Mhm.
Would you say that the homeworks are helpful for studying?
Yes, I think your homework is super helpful. Yeah, so here's the website, right? It doesn't look like much, but when you click here, it brings you to this. So right, you'll talk about atomic structure. We can go to here, and then it gives you a whole bunch of stuff that you can read about in your leisure. Or the mole is right here. Determine a molecular weight if you need help with that. Empirical formula is super important that you talk about in a little bit. That gives you a whole bunch of questions, right? But see here, they have example 1, and then it'll drop down and give you an explanation there. So I think that's a really helpful resource. If you go over there, I'll show you this on the Canvas page. I'm gonna have to do a mobile. So on Canvas, in your section, if you go to this resources and contacts page, and then I'm right here, I'm your instructional assistant. Here's the link to all review session recordings. So that's where I'm gonna post all of these. If you click on that now, these are all of the ones from last semester. So any additional practice problems I have in the answers, some of them are like before test reviews. So you can watch those. I go through usually the practice exam that Dr. Gonzalez gave. So a couple of them there along the way, the final review and stuff like that. So those are all there. We're doing the same course as last semester, so that should be pretty similar in terms of timing for what's available on those practice problems. Yeah, I think that's my tips and tricks. And go to class. I think I know it's easy to skip, but go to class is always super important. As much as you can. Any other questions? I know there's not a lot going on right now, but
For the, I could go grade, I know for Calvary,
Mhm.
like she like rounds it up.
Mhm.
Does Bengali do that too?
yes, yeah, so I think it's 75% you need, so as long as you have a total grade of 75% at the end of the semester, then that bumps you up to 100.
Okay.
Yeah, I think that says it in the syllabus, if I'm correct. It might not, but I do know that we rounded that up at the end of the semester, as long as you had 70% participation, or 70% overall, right, between participation and correct answers. I will go through and grade the iClicker. If you miss a class, sometimes he excuses your absence, sometimes he doesn't. If you're sick, really, it's okay. It's not gonna be that big of an issue. But I will go in and grade them. So if you have like 6 iClickers for the day, then each one's worth like 0.8 of a point. So if you get one wrong, it's not gonna be an issue. It doesn't contribute that overall that much to your grade. So don't freak out about iClicker. That's supposed to be like 100 points, as long as you show up. Anything else? It's a little before 7:15, but if you have nothing else, you're more than welcome to leave. If you want to just talk to me, that's fine. If you want to stay here until 7:15, that's fine. But yeah, if there's no other questions, thanks for coming. Hopefully I'll see you next week. And I'll see you in class on Friday. Or maybe Monday. I just And then next week, I'll use the projector the whole time, so it'll be easier to see. I promise.
Code for the, free book for the homework, or do we just need to buy it?
You need to buy it. I think that's part of the course stuff. Yeah, I think there's like a 2-week free trial you get in the meantime,
Yeah.
but I think that is something you purchase.
Thank you.
Yep.
That's right.
You too. Thanks for coming. You're welcome. Thanks for coming.
The owl thing and Canvas, is there anything else?
No, the homework, it should all be through OWL, so as long as you have your assignments done, it should be good. Yeah, and then I think they're due Sundays, so just sure you do that on the weekend.
Thank you.
Thank you.